Hello everyone, welcome to a new segment of Flutter Tips. My name is Nicolás and today we're going to be looking at the Decorator Pattern in Flutter and Dart. What is it? So basically it's a pattern that adds behavior to objects dynamically without changing their code. So let's explain this a little bit more. The decorator pattern is a structural design pattern that lets you attach new responsibilities or behaviors to objects at runtime by wrapping them inside their objects that implement the same interface. So this basically means that we have an original class, an original object, and we want to extend the functionality. We want to add more logic in that class. With this pattern, we are not going to change the code of that class, but we are going to wrap it in a different class that will be the one that extends the functionality. We will see that in example later. So in simple terms, you wrap up an object with another to extend its functionality without modifying the original class. How that works, we call starts at the outermost decorator. Each decorator adds its behavior, then delegates to its wrapper object. Eventually, the base component executes, and the result bubbles back through each decorator. So that means that we have an original class that returns some functions, and those functions have some logic. On the decorator that we will create, that's going to be a different class. We will be sending that through the parameters that original class, and we will be having the same functions because that will be under the same contract. It will be implementing the same interface. So in the same functions, we're going to be calling the functions for the original class, and then with that result, we are going to do the new logic, the new functionalities that we wanted to extend from that object. Let's see it on the example so we can understand better how it works. We have the abstract class here, the data source, that only has one function, that is the fetch data. We have other classes. The first one is just the concrete implementation of that abstract class. It's called a file data source, and it will have the logic of the fetch data. That's basically just by printing a hello world. We have a base decorator class. We're going to be using this class to attach to or to use the other different decorators that we are going to create. And this one has basically this will return the same result, the same hello world from the concrete component, from the concrete implementation of the base class of the interface. We have a login decorator. This now is one of the classes that we are going to use to be extending the functionality of this original hello world, of this original behavior. On this one specifically, what we are going to do is just to put some prints. So we are going to be like logging, adding the functionality to log during on the runtime of this hello world. And we have another decorator that will also be changing the behavior of all the result of these other classes, and this one is to convert to uppercase. Let's see how we implement this code, how we use it. So we instance the base class, that is the file data source. Let's remember that this one, the only thing it does is to return a hello world. That's our original behavior. Now we want to extend that functionality. Now we want to not only print hello world, but also doing some logging, doing some output. So in the login decorator, we send that base class, and that's the one that will be extending the functionality. So if we remember, if we see the code again, we have this login decorator that receives in the parameters this hello world, basically this base class. We add some prints and we call the fetch data from that base class. So this is the moment that it returns this hello world, and we print that data. So that's why on this login decorator, we extended the functionality to print this text. And after that, I'm gonna add another decorator, that is the uppercase decorator. I'm gonna continue extending the functionality. In this case, I send through the parameters the result of the login decorator, and basically what it does is just to transform the result of that fetch data into a uppercase. If we check the output, we have the behavior of the printing of the login decorator on fetching data. We have the original string, the original hello world from the base data source, and we have the final result, that is the result of the base data source of the hello world transformed into uppercase. We implemented two decorators here to extend the behavior of this original class. So why we use it? To avoid subclassing exposure, too many combinations of features. As you can see, we are fragmenting all the code. We are separating into the different decorators, the functionality, so it's more organized. The extend the behavior per object, not per class. We are not modifying any class. We are just extending the behavior of an object. That's the one of the key things for this pattern. To keep the original class code untouched, basically what I mentioned, that will meet the open close principle and combine multiple behaviors by stacking wrappers. That also means that, for example, if I don't want to use the uppercase decorator, I can just remove this line and continue just using the login decorator, and I will be extending the base class just by adding some print, some blocks. Or if I don't want to do any print, do any logging, I just want to remove this line and just leave the uppercase decorator. So in that case, we will be just transforming that hello world into uppercase without any prints, without any logging. The structure, basically what we saw in the example component, the concrete component, the decorator, and concrete decorators. We can use as many decorators as we want, but it's always recommendable to not use a lot decorators, because there will be like a stacking by each new decorator. So we can also make a very confusing code in that. So we don't want to abuse of this pattern. So in summary, the decorator equals the dynamic composable behavior extension. Basically, we wrap, we don't modify, keep all decorators small, focus on composable, common flutters, widget system, and many design patterns. So this is the decorator pattern in Flutter, basically. Thank you for watching this new Flutter tip. I hope you find this very interesting in your code. And yes, let's see you on the next Flutter tip.